Hello all, today we are going to be proving triangles are similar by side, 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 and side, angle, side similarity. Let's get started. Side, side, side similarity states that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So that means that the corresponding side lengths create a ratio, and all of those ratios will have to be the same in order for the triangles to be similar by side, side, side similarity. So triangle ABC here and triangle RST, in order to know that if these triangles are similar, then the corresponding sides, for example, AB to RS, BC to ST, and CA to TR would all create ratios that are equal, which we would then know that triangle ABC is similar to triangle RST.
Alright, in this example 1, we have to see if either triangle DEF or triangle GHJ is similar to triangle ABC. So there's a lot going on here. There's three triangles that we have to compare and see which ones are actually similar to each other. Well, let's first compare triangle ABC and triangle DEF. Now, in order for these two triangles to be similar, the ratios of the corresponding side lengths of all three side lengths have to be equal, the ratios. Alright, so then if we're going to compare triangle ABC and DEF, let's take these short sides of each triangle. Alright, so then the short side of, we're going to start with the triangle ABC. The shortest side of triangle ABC is 8, so AB. So we have 8 over the shortest side of triangle DEF, which is 4 over 4. So our ratio 8 to 4 can be reduced by 4, and so the ratio is 2 to 1. Alright, so then that ratio is 2 to 1, so let's check the long sides. So the longest side in triangle ABC is 12 AC, so 12, 2. And then the longest side in triangle DEF is 8, so we have 12, 8. And real quick, notice how I'm always starting with the triangle ABC, or at least the same triangle every single time when I'm trying to check to see if all the ratios of the corresponding side lengths are the same. I always start with ABC. Doesn't have to be, but make sure you always start with the same triangle. So then going back to my problem, the ratio of 12 to 8 can be reduced by 4, and I get 3 over 2. So right away, if you notice that your math is 100% correct and you notice that the two ratios that you set up are not equal to each other, we cannot say that these two triangles are similar. So then ABC and triangle DEF are not similar. So now we have to check to see if actually GHJ is similar to ABC. Okay, so we had a typo here, so make sure you change that in your notes. So we're going to do the same thing. Compare the short sides first. And so we have 8 to 16. And then reduce that by 8. We get 1/2. So the short sides of triangle ABC to the short side of triangle GHJ is 1 to 2. Let's check the long sides. 12 to 24, which can be reduced down to, by 12, which is basically the same thing as 1/2. So that works out. So we're 2 for 2 right now. So the remaining sides is the middle length of each triangle. So then triangle ABC we have BC, and then which is 9, and then we have 18 to be the middle length, HJ, which can be reduced by 9, which reduces down to 1/2. So then all three ratios of the corresponding side lengths of both triangles are equal to each other. So therefore both triangles are similar to one another using side, side, side.
Okay, in example 2, we are going to use the side, side, side similarity theorem to find the value of x that makes these triangles similar. Well, our first step in all of these problems is to find out our scale factor. Now, looking at these triangles here, you can see that in this first triangle there are two sides that are known, and then in the second triangle that are also two sides that are known. But we want to use two known sides from both triangles in order to set up our scale factor. Those sides will be BC, which has the length of 4, and EF, which has a length of 10. So I chose those two because neither of those have an x. Because neither of them have an x, it's easiest for me to find the scale factor. So I set up my ratio. BC to EF is 4 over 10, which then divided by 2 is 2/5. So 2/5 is my scale factor. So now that I have my scale factor, my second step is to use that scale factor to set up proportions in order to solve this problem. So I take my scale factor of 2/5 and I set it equal to two side lengths that are corresponding, where one of them has an x. So I'm going to choose the next biggest side length, the medium side length, which is x minus 3, which corresponds to the side length DE over 20. So as long as your side lengths are corresponding, you can choose any of them. So now we are going to cross multiply. So I'm going to multiply 2 times 20, which is equal to the cross product of 5 times the quantity of x minus 3. 2 times 20 is 40, which is equal to 5 times x, which is 5x, and 5 times negative 3, which is negative 15. I add 15 to both sides to cancel out the 15 on the right-hand side. I'm left with 55 equals 5x, divide by 5, and x is equal to 11. So what that means is that x equals 11 makes the triangles similar. And I know that because I used an original scale factor in order to solve this proportion.
All right, this slide's about the side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides that include these angles are proportional, then the two triangles are similar. So if you look at the diagram, we already have two angles that are marked. So we can say that angle X and angle M are congruent to each other. Okay, so that works. So then when we talk about the sides that include, or that have the include angles of X and M, we're talking about the sides that are adjacent to those angles. So XZ corresponds with MP. That ratio needs to be equal to the ratio of the other adjacent angle to that adjacent side to that angle, XY to MN. These two ratios need to be equal, along with the included angle need to be congruent in order for you to use side angle side similarity. So because we know that angle X is congruent to angle M, and the two ratios XZ to MP is equal to XY to MN, if that's true, then we can say that triangle ZXY is similar to triangle PMN using side angle side.
And now we are going to prove these two triangles are similar, and more specifically overlapping triangles. So we need to show that triangle VYZ is similar to triangle VXW. Now whenever you have overlapping triangles or anything where the triangles intersect over on top of one another, you should always draw them separately. So my first triangle is the larger one, VYZ. So I'm going to draw VYZ separate from the picture. My second triangle is triangle VWX. So then I'll draw VWX outside the picture. Now I am given some information about these triangles, so I'm going to fill that information in on the new triangles that I drew outside. So in my smaller triangle, my smallest side has a length of 4, and the side across from it has a length of 5. Now, if I look to my picture, the long side, VY, has a total length of 8 plus 4, so that means VY's length is 12. And on the right-hand side, VZ, if I add those two lengths together, then my total length would be 5 plus 10, which is 15. So VZ has a length of 15. So now that I have two sets of corresponding sides, I'm going to set up ratios to find the scale factor. So YZ corresponds, this should be YV. YV corresponds to WV, so let's set up those lengths. YV is 12 and WV is 4, so 12 divided by 4 gives me a scale factor of 3. Now let's set up our next corresponding sides, VZ to VX. Well, VZ has a length of 15 and VX has a length of 5. So if I divide 15 by 5, I get 3. So far I know that the blue triangle is 3 times as big as my purple triangle, as long as we have one angle to know that the triangles are similar. Now, in between each of the side lengths on both my triangles, I have an included angle, and that angle is angle V. Now, angle V is congruent to itself because of what we learned last unit, which would be the reflexive property. So I have 2 sets of sides, which gives me my 2 S's, and then the angle in between them, angle V, which now I have side angle side similarity. So I can say that triangle VYZ is similar to triangle VWX by side angle side similarity. And that's all, guys. Make sure you're asking questions and writing down notes that you have for class tomorrow.